Good morning, everyone. Today we're going to be talking about some statistics, which I personally love. And to do that, we have an objective, namely that by the end of this lesson you'll be able to use measures of center, mostly median and mean, and two, to use measures of spread, which our only one for this lesson is going to be range, to describe data shown on a dot plot. So, just in case you didn't know, data is numerical data. And for measures of center and measures of spread, we're going to talk about those a little bit later. The very first thing we need to talk about is actually an outlier. And that is a data value so far above or below most values that you may consider omission, which basically means pretending it isn't there. So for example, if I had the numbers 1, 2, 3, 4, 5, and 4 million, in a way I could say, oh, well, this data pool goes from 1 to 4 million. That being said, well, not really, because most of the values are somewhere between 1 and 5. There's just that one that's 4 million. So we might consider omitting it. We might consider sort of pretending it isn't there, because sometimes in the real world when this happens is when there was some kind of a data entry error. Like the person that was typing the values into the computer accidentally had a typo where they held down the 0 too many times or something like that. Another time when it happens is sometimes biologists will be measuring how much some type of species weighs, or how big they get, or how tall something might get, or the width of some bird's wingspan. And when they get one that's that big, they kind of go, I don't know, is that a huge version of this species? Or is that just some other species that has some traits that look like that species? This would be like, we found 5 fairly regular sized ants and an ant the size of a dog. Well, that ant the size of a dog probably isn't really an ant. It's probably just something that looks like a huge ant. Now for measures of center. A measure of center is a measure of center tells you where the middle of your data is, or a close representative value. We've got two main ones. Our two main measures of center are mean and median. The median is the exact middle number in a set of data. That is for odd numbered sets. Then we say, or the number in between the two middle numbers for even numbered sets. Now I'm going to explain this whole even numbered sets versus odd numbered sets thing with two examples. Let's say example 1. If I have data points 1, 2, 3, 4, 5, and 6. Actually, no, 1, 2, 3, 4, and 5. Well, what's the middle number in 1, 2, 3, 4, and 5? It's 3, because there are two numbers below it and two numbers above it. Now for example 2, let's say I've got 1, 2, 3, 4, 5, and 6. Let's see. my median 1, 2, 3, 4, 5, and 6. Well, it's not 3 because 3 has 2 numbers below it and 3 numbers above it. It's not 4 because 4 has 2 numbers above it and 3 numbers below it. It's right between 3 and 4. I've got to say it's 3.5 because that's what would be right between those two middle numbers. Now for mean, mean is what most people are talking about when they say average. It's a measure of center you find by adding number values of all points together and dividing by the number of values. So for my example here, let's say I've got, again, 1, 2, 3, 4, and 5. The mean for that is going to be 1 plus 2 plus 3 plus 4 plus 5. And it's going to be divided by, let's see, how many data points do I have here? I've got 1, 2, 3, 4, 5 of them. Divided by 5, that means my mean is going to be 1 plus 2 is 3, 3 plus 3 is 6, 10, 15. 15 divided by 5. That equals 3. The mean for this data set is 3. Now this last measure of center that I'm going to talk about, this one is not in the book. It's still really useful. I don't know why they didn't include it because, again, it's a very useful measure of center. And it's usually fairly easy to find too. This last one is mode. The mode is the number value that comes up most often. So let's say I've got 1, 2, 3, 4, 4, 4, 4, 4, and 5. Well, it goes from 1 to 5, but 4 comes up, let's see, 1, 2, 3, 4, 5 times. So 4 is the mode for that one. Because it occurs 5 times, and all other values only occur once. Now take a minute, take a nice deep breath. Now let's talk about our only measure of spread. So measure of spread is fairly self-explanatory. A measure of spread gives you an idea of how spread out your data is. An idea of the range of values from bottom to top. Now we've only got one measure of spread that we're going to talk about today, and that is range. Range is the difference between your highest and lowest values. Example, if I have 1, 2, 3, 4, and 5 again, well, my range is the highest value, which is 5, minus the lowest value, which is 1, and that equals 4. My range is 4 because highest value is 5, lowest value is 1, 5 minus 1 is 4. Now let's talk about a real world example of all these things. Let's pretend for a moment that I am starting a shoe store. And starting a shoe store, I ask an important question like, what size shoes do most people wear around this neighborhood? And because I need to know, I asked 10 people what size shoe they wear in the neighborhood. Ignore the red dot for now. We're going to come to it at the end. And 2 people tell me, oh, I wear a size 7 shoe. And 1 person tells me, I wear a size 8. And 4 people tell me, I wear a size 9. And 2 people say they wear a size 10. And 1 person says 11. Well, for my measures of spread, my only one that I have right now is range. And ignoring the red one, let's say, alright, from 7 to 11, 11 minus 7 equals 4. The range is 4 shoe sizes. We're pretending that half shoe sizes don't exist for this. And for measures of center, I've got 3 of them. I've got my median. So let's see, for my median, well, I've got 2 7s, so I'm going to say, what's the exact middle number in these 10 numbers here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it's going to be right between the 5th and 6th values. So I've got 1, 2, 3, 4, 5, 6. Oh, so it's right between these. These are both 9, so it's right between a 9 and a 9. Well, that's another way of saying 9 is my median. My mean, I calculate by saying, alright, I've got a 7 plus another 7 plus an 8 plus 4 9s plus 2 10s plus an 11, all divided by 10 values. So that comes out to 89 divided by 10, which means my mean is 8.9. Now finally, the last one that, again, the book doesn't show you, but it's still useful, is mode. Which one of these comes up the most often? Well, you can see right away on a dot plot like this, it's 9. So now, if I'm trying to open this shoe store, what size shoes people wear is pretty important. So with this information, it looks like most people wear close to a size 9. So if I am trying to figure out what size shoes I need to buy to supply people in this neighborhood with shoes, I'm going to say, okay, I'm going to want to buy a whole bunch of size 9s. Because that's the one that the largest number of people, the mode, use. It's the median, and the mean is something really close. The mean is 8.9, and there's no 8.9 size shoe, so I'm guessing that anybody that would be an 8.9 is going to wear a 9 anyways. So now all this information shows me, okay, I need to have shoes that are within 4 sizes or so of size 9. But let's pretend I asked one more person, and that last person is a giant. And I look up at this giant and I say, hello up there, what size shoe do you wear? And he says, I wear a size 21 shoe. That is going to mess up a lot of things, like my range. Now my range goes with this outlier. My range goes from size 7 to size 21. So that's 21 minus 7 is equal to 14. That added a whole 10 sizes to my range, even though there's only one person outside of an 11 in this data set. But still. And let's look at the median with the outlier. Well, the median with the outlier doesn't change much. It's still a size 9. But the mean would change a whole bunch because we'd have to add 21 to that whole data set in there. That would make our mean a whole 2 sizes larger. That's why sometimes we omit outliers, like that red dot.